Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cindy.
And I'm Lucia. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. You saved me from having to read all of that. So, Lucia, where do you go to school and what grade are you in?
I go to Del Rio Elementary and I'm in 4th grade.
How is 4th grade?
Good.
You go to school longer now, don't you, than last year?
Yes.
And is that still good? So you're all right with it?
Yeah.
Okay. What is the best thing so far, because you're more than halfway through 4th grade now, what is the best thing about 4th grade so far this year?
We get, at the end of the year, if we've gotten honor roll three quarters, then we get to go get ice cream and lunch.
Oh, awesome. So you've already had 2 quarters. Have you been on honor roll yet?
No.
Okay. So
Oh, yes.
Oh, you have? Have you been on once or twice? Because you've had it 2 times.
Twice.
So all you need is 1 more, right? You think you'll get that 1 more? Yeah, there you go. So you said you're going to get ice cream?
Yes.
What's your favorite flavor?
Vanilla.
Yeah? Do you put anything on top of it, or you just like the vanilla itself?
I put chocolate syrup.
Ooh, there you go. All right. Well, oh, yeah, you got a ding, ding, ding on that. So somebody in the back likes the chocolate syrup also. All right. Hey, are you ready to help me with the social media problem of the day?
Yes.
All right, let's take a look at it together. So every day, the producers send out a social media problem of the day, and people submit their answers, and then you and I will take a look at it, all right? So it says, what is the answer 65% of 120? So do you have any idea what that is asking for or how to do that type of problem?
No.
All right, well, you're in 4th grade, right? You probably haven't started percents yet, have you? Well, good, you're gonna start them today, young lady. Here we go. So what is the highest percent you can get on a test?
100.
100, right? And if you got 9 out of 10, do you know what percent that would be?
99%.
90%, not 99, because if you got 10 out of 10, you get 100. And if you got 9 out of 10, you got 9/10 of it, or 90%. That kind of makes sense?
Yeah.
What if you only got 2 out of 10 right?
20%.
20%. All right, so you got the hang of it, right? What about 6 out of 10?
60%.
60%, all right? Now this says 65% of 120. Now if it said 65% of 100, it would be easy to be 65, right? But it says 65% of 120, so it's gonna be a little higher than 65, okay? So let's take a look at our options so far. Do you think it could be A, 60?
No.
No, 'cause that's not even 65, is it? And remember, it's gonna be a little higher than 65. So what about C 100? Do you think it could be that high?
No.
No, that's a little too high, isn't it? So we have B 81 and D 78. Out of those 2, which one do you think would be the better option?
B.
You think B? All right, why do you think B over D? And you go, I don't know, I just like 81
Yeah.
over 78. I don't know, who knows, right? So, all right, so here we go. So let's think about it. 60% of 100 would be 60, right? And if we have at 5, that's like half of 10%, okay? So if I got, just think of tens and think of a half, all right? So we've got the answer 20, all right? So what's 10% of 20, you think?
1.
How many times can 10 go into 20?
2.
2, right? So 10% of 20 would be 2. Okay. So if I have 6 of those, what's 6 times 12? Or 6 times 2, I'm sorry, I gave you the answer. Or no, it would be 6 times 12.
6 times 12 is
Well, what's 6 times 2?
12.
Okay, and then we already had 60, right? So what's 60 plus 12?
72.
72, right? So we're on track, all right? And what's half of 12?
6.
So 72 and 6.
78.
All right, so what do you think? Do you want to go with 81 or do you want to go to 78?
78.
Are you sure? Because you were feeling pretty good about 81 before. You think it's 78? Now you're just learning percents right now, right? Are you sure you want to stay with 78?
Yes.
All right, let's take a look and see if it is correct. There you go, 78. First problem done, all right? And you got a little bit of percent in there right now. So, I mean, you got a lot to learn about percent, but that was at least your first one, all right? All right. Phone tutors are available most Tuesdays and Wednesdays between 3:30 and 5:30. Phone numbers are at the bottom of your screen periodically throughout the program. Time now for today's Math in the News. All right, today's Math in the News, we have a celebrity with us. This is Steve Sanders. How are you today?
Hey, wonderful.
Nice
How are
to
you?
see you.
Thank
So you work here at the Kern County Superintendent of Schools
I do.
all the time because we're only here on Tuesdays and Wednesdays, but you're here every
Yeah.
day. All right?
Definitely.
What is your role with the county office?
So my official role is Chief of Staff. They call me the Chief of Stuff. And in that role, I support our elected Superintendent of Schools, Dr. Mendaburu,
Okay.
and then I oversee several programs. So I work with the Communications Department, an agency called the Kern County Network for Children, and then our local zoo, California Living Museum.
Yeah, I was going to see. So we can see some of that on a quick little bio of
Yeah.
you here on this slide right here.
Yeah.
And how long have you been with the county office?
I just hit 25 years
Yeah,
last
there
month.
you go, 25
Yeah,
years. All right, so
exactly.
you've been here a little longer than do the math. This is our 22nd, 23rd
Exactly.
season. So,
Yeah.
and you've been running the show since it's started.
No, I've had different jobs here at KCSOS.
Oh, all right, because I thought when we
Yeah.
started, like you were, I always kind of
Yeah,
thought of
I've
you
been
as
in
my
this
boss.
job for about 12 years. And
Okay.
then prior to that, I had the opportunity to work with all of the early childhood education programs. So Community Connection for Childcare, our preschools. And then prior to that, I worked as the director of the Kern County Network for Children, which we'll talk about.
Okay, well, let's take a look at the next slide right here. So you've been here for 25 years and you've had 5 different superintendents.
Yes.
So how long were you with Kelly? Dr.
So
Blanton?
I was with Kelly, Dr. Blanton, about a year. So I worked with him at the tail end of his career when
Okay.
he retired. Then Dr. Ryder took over. And Dr. Ryder worked for, I want to say, 2 terms, so it would have been close to 8 years.
And that's kind of you at the beginning a little bit there, right?
Yeah, that's when my hair wasn't as gray.
You know, that's when I had some too. You know?
Exactly. And then Dr. Frazier, who was our first female superintendent
Right,
in
I
our
remember that.
history. And then Dr. Barlow, and then since July, I've had the opportunity to work with Dr. Mendaburu, who actually was my principal of
Oh,
my
that's too
kids'
funny.
school at Almondale
Ah,
Elementary
there you
School.
go. And you said
Yeah.
since July, and he actually took his spot on July 1.
Exactly.
And I remember talking to him because that's my birthday and it's his birthday.
Yeah.
So that was pretty
was a
funny
big
to see.
day.
You know, like, hey, July 1, a lot of stuff happens on that day.
Exactly.
And I'm not going to ask you, you know, like, hey, did you have a favorite superintendent
Mm-hmm.
or anything like that? But have any of them, I know you've only worked with Kelly for a little bit and John since July, but any kind of like funny things that you remember, you're like, oh yeah, you know, I remember.
Well,
this
they all had
happened.
their own personalities and brought their own way of doing things to the office. What I like to tell people is each superintendent was the right person for the right time.
Yeah, there you go.
Right? They brought certain skills that we needed, and so the funny stories I'll keep to myself.
Okay.
How's that?
Well, maybe later on social media you
There
can
you
talk
go.
about that stuff, but we will keep everything here. So the Dream Center, tell us a little bit about this.
Well, everything we do here at KCSOS is about partnerships. I mean, Do the Math is a partnership with the industries that you go and talk to and support. And so the Dream Center is an amazing place that serves emancipated foster youth and homeless youth. It's located downtown, and it's really a one-stop resource center. So multiple services where kids can come and get everything from resume help to snack bags to showers to help with housing.
Okay. And we can see some video of that right
Yep.
there. And and that's right across the street.
Yeah, it's close by,
Yeah.
in a great location right downtown.
So this, pretty new. I mean, the last couple of years we've been hearing a lot about it with all the different levels of education in this.
Right.
But talk a little bit about the pledge.
So that was really an initiative that Dr. Barlow spearheaded, and it was a way to bring together all of the folks concerned about education from pre-kindergarten all the way through college and career readiness. So it really, although we've had collaboration in the past, this stepped it up a game. And we now have, as an example, out of that something called the Kern Integrated Data System, which is a one-stop database for all student information that can be uploaded every night.
Instead of looking at different places
Exactly.
and trying to find things, you've
Right.
got it all in one spot.
Exactly.
And AmeriCorps.
So AmeriCorps, think of AmeriCorps as the domestic Peace Corps.
Okay.
So for years, our office has had an AmeriCorps program where we get young folks. Oftentimes, it's their first chance to do community service to that level. They go out in the community and do all kinds of projects, from food insecurity to tutoring and other nonprofit work.
And I know a lot of students and adults are familiar with a lot of these, but
Mm-hmm.
probably they're more familiar with this next one we're going to talk about, and that's the Holiday
definitely.
Lights That Come.
Yeah, so this was our 21st year that we just finished. It was a record year. For 3 years, we did a drive-through because of, initially COVID,
Right.
and then kept that. And then this year, we brought it back inside the zoo, had over 75,000 people that attended. And in fact, I met today with Josh Barnett to already start talking about next year.
Yeah, I was going to say, because it was funny, because the night I went out and helped with the train one night, and he happened to be there that night,
Mm-hmm. Right.
and one of the other guys was like, hey, the guy that was doing all the lights is here, and
Oh, yeah.
he was able to talk to a few folks and stuff like that.
It's a great local success story. A guy had a dream as a kid and built a business, and now he has shows all over the country.
Yeah, and this is one of the major ones in the
Yeah.
entire country.
Absolutely.
All right.
Yep.
Well, we certainly do appreciate you coming down and
Thank
spending some
you.
time with us, but I'm not going to let you go quite yet.
All right.
You ready to play a game?
I'm ready.
All right, here we go. So I'm going to give you a board and I've got a board. All right. And this will be you can go ahead and empty those out. They're just a bunch of different pieces,
Got it.
right? And they're
Looks like
different
Tetris.
sizes. Right. So there's sizes 1, 2, 3, 4, 5,
Got it.
so on. So what's going to happen is we're going to have these pieces are going to be our blockers.
Okay.
Okay, so we're going to fill these in, and each of us are going to get the same amount. I think it's 6 or 7. Anyway, I think it's 7.
Okay.
So what we're going to do is we're going to roll these dice.
All right.
Okay, and wherever the dice show us, that's where we're going to put these blockers on our board.
Got it.
Make sense?
Yep.
All right, so here we go. So just go ahead and start putting them. So we got like A6.
Oops. A6. Hey, that's my
Hey,
piece.
take
Come
that
on.
one. All right, so I got D2,
F10,
C5,
C5.
E5, D4, F2, and B2.
And D4.
All right, so we'll just make sure that ours are identical, we're the same.
Yep.
All right, so now what we have to do is we have to take all of these different pieces and put them in here.
Okay.
And it's amazing that no matter how we roll these and put the blockers on, there's always a solution.
Okay.
I mean, it just baffles me that there are
I'll
that
trust
many
you.
different possibilities.
Yeah.
No matter what comes up here, there's always a way to solve this puzzle.
Okay.
All right, so
Start putting
go ahead and start. Whoever fills it in all the way first will be the winner today. And I'll have you know I have never won this.
Well, that's good.
I have played with
That's good to
different
know.
people and have never won it yet. And
No, that's not gonna work.
all right, so we'll see. I mean, I can already tell that I'm stuck
Yeah,
there.
Same here.
So, what are you thinking about right now as you're doing this? Because I'm thinking about like, all right, let me just.
I'm thinking Mike Kushan has more pieces than me.
Hey, easy.
No, I'm just kidding. It's not easy because you think you can see it, and then all of
Right.
a sudden,
And the thing I think of sometimes is let's take the odd, like the weird shapes, and kind of put those somewhere, and see if we can get those done first.
I'm gonna do that.
Nothing like seeing a couple of grown guys struggle with a puzzle here, and But kind of reasoning, spatial awareness, and where things can kind of go and not is something that students work on, or sometimes they're asked to do it, but I think something like this, a little more concrete, helps them out also
Absolutely.
to go ahead and start. Well, let's see, I think I've got, uh-oh, I'm getting close, I think now. Oh, look at that, Steve, I came all the way down to 1.
I know,
I
see,
almost
that's
got it.
that's the hard part.
All right. Yeah, of course, you know, and it's like, they take it all apart, but it may not necessarily mean I need to take it all apart. And we're not going to spend too much time doing this, and we may just have a draw. Neither one of us can do it.
I was going to say, I
come
think
over
it's
here
a
and do
draw.
one of them and be done within like 10 seconds.
That's great. What's this game
But
called?
so this is called
The Genius,
Genius
Square. All right.
all right. So that's the name of the game. Anyway, you cool with the draw?
Yeah,
All right.
it was great.
No, perfect. They're giving me the horn like that. All right. Anyway. So anyway, Steve Sanders, the chief of stuff.
Yep.
Otherwise known as Chief of Staff here at KCSOS. And we certainly do appreciate all that you do for the program, because as you said, one of your responsibilities is KETN, and there's a lot of different programming that you guys do, but we certainly do appreciate you letting us take 2 hours out of the week to do the math.
We love to do the math, so keep it going. Another 21 years.
Yeah, there you go. Well, we've already, this is the end of 22.
22.
I don't know
Another
if I'll be
22
doing it for
years.
another 22 years, but I certainly do appreciate the opportunity. 636-4357 is that phone number. We have Lucia, a 4th grade student from Del Rio School, in studio with us and working on some long division. So girls, head on over to the board and we've got a problem all set for you. This is one of the problems, Lucia, that you brought in with us. So we're going to have 5,605. And I guess you can say that's inside the house, if that's the way you guys talk about that. So 5,605, 5605.
05.
Well, you know what? Take the 5 out of the middle then.
Take the middle 5 out. It was 5,
So
6.
5605.
Yeah.
And you can erase.
You can erase with the back of the, just erase it.
There you go. Just get rid of that 5. And if you want to, you can move the other ones over. So you can just put the 05 right after the 6. So 05.
And then 5.
All right.
And then
And that is going to be all
division.
divided by 8. And if you could explain to Cindy how to solve that problem.
Okay, so 5 is less than 8, so you put an X on top of it.
Okay.
And then you add the first number to the second number, so that's 56. And then 56 divided by 8 is 7. So you put a 7, and then those two together equal 56, so you subtract it from 56.
So you multiplied 7 and 8, got
Yes.
56, and subtracted it from 56, okay?
0. And then you bring down the 0, and it's another 0. And then you bring down the 5. And divide. But you cannot divide 5 by 8. So instead, you bring up a 0, and then remainder.
So before you finish, what about, you know when you brought this 0 down? Whoops. You should put something above it before you bring down the 5. So when you said, okay, bring the 0 down, and the 5 wasn't there, can 8 go into 0, 0, 0?
No. So you put a 0.
Yeah, so you need an extra 0 in your answer to hold that place for that 1 0 that's there. So 0 above 0, and then like you said, it can't go into 5, so another 0, and then now you can put your remainder. Okay, looks good.
All right, so you are pretty confident that that's the answer. Do you have any idea how you can check that to make sure it's the answer?
You can multiply 7 and 8, And then if the answer is 560, then you know it's right because the remainder is 5 and you can add 5.
There you go. So you could actually do that in your head, can't you? Right, because 7 times 8 is 56, right? And then you got those zeros right there. So nicely done. So you feel pretty good doing long division, right? Well, for your great work so far today, you've got yourself a meal courtesy of our friends at Chick-fil-A, so congratulations on that. So you know what comes after dividing like that, long division? Dividing with fractions. But we're going to do that in a little bit. Right now, we're going to talk a little more math.
Hello, my name is Omar Areguin, and today we're going to be finding the area of an irregular shape. An irregular shape is a shape that has different length and sizes. But to find the area of an irregular shape, you have to first simplify it into simpler shapes, which you could do it like this, or even add a part like this. But today I'm going to show you how to do it like this. And first, I am gonna find the area of this shape. But to find area of a shape, you have to first follow this formula, length times width, which we are missing no measurements, so we could just multiply across 6 times 8, which will equal 48. So the area of this shape will be 48 meters squared. And now I am going to find the area of this shape. Since this whole thing is 10, you look over here, which is this parallel side, which will be 6. So that means this 6. And to find this, you have to subtract 10 minus 6, which will equal 4. So the measurement of this side will be 4 meters, which we have to multiply now length times width, which will be 5 times 4. Which when you multiply across will equal 20. So the area of this shape will be 20 meters squared. And now to find the area of the whole thing, you have add the two measurements, 48 plus 20, which will equal 8, and this will equal 6. So the area of this entire shape will be 68 meters squared. And this is how you find the area of this irregular shape.
And always nice to have those kids talking a little bit of math. As a matter of fact, you have an opportunity to talk a little bit about math, whatever topic you would like to. So you can see the promo on the screen right now. We have some dates coming up after school towards the end of May. And all you have to do is come up with a math topic that you would like to talk about. And it could be anything in the world as long as it has to do with math. And as long as you're comfortable talking about it, it would be as though you're the instructor telling us about that math, right? So much like when you were dividing just before, right? If you wanted to come in and show others how to divide like that, you could come in and talk about division. And then maybe if you had another way to divide, you could talk about that. And that would be your math topic that you could do on Let's Talk Math. Does that make sense?
Yes.
Sound pretty cool? Indeed it is. It is pretty cool because we had a lot of students sign up for it last year, and we're looking for even more students, and you could be at any grade level at all. So if you're in 3rd, 4th grade, you could come in and do that. There's a lot of kids that are in middle school doing it, and there are even students in high school going to come and do it. We've even had kids that have, because this is the 22nd year of Do the Math, so there are kids that started watching Do the Math when they were like 8, right? And they're now 30, and they've graduated college, and even they can come in and talk a little bit about math. Do you know when you're going to talk about math?
Always.
Oh, you know, that is the perfect answer, because you are always going to be talking about math. For as long as you live, no matter what you do, you're always going to have to know a little bit about math. Sound good? All right. Well, right now, we do have a special opportunity for a visit from the Bakersfield Museum. So the Bakersfield Museum is in Bakersfield. It is the Kern County Museum. Got me thrown off for a second right there. But the Kern County Museum in Bakersfield. Ashleigh is with us once again. And last time you brought an abacus with you.
Yes.
And that was pretty sweet to see that. And a little bit about how old it was. That was from the Civil War times, correct? Mm-hmm. Yeah. All right. So you've got something else with you here today.
Yeah, I have brought another artifact.
All right. So before we start talking about it,
Yes.
Lucia, do you have any idea what that could be?
No,
All right. What do you notice about it?
it's wide.
Okay.
It has numbers on the top.
Okay. Which is a good thing since it's a do the math program, right?
Yeah.
Okay.
And there's little slots,
Okay. Any idea what the slots are for or what the numbers might mean?
coins,
Why do you think coins?
because they're about the same size as the coins.
Okay. So the cylinders, the little slots, are about the same size as a coin, right? So Ashleigh, what can you tell us about this piece?
Well, are you wanting what the item is now?
Well, do you have any history about it first?
Well, it is, you're correct, it's used for coins. It is, well, you see these little levers here?
Yeah.
Here, why don't you press down right there? Yep, keep pressing, keep pressing. There you go. So, do you have any idea why that lever would be there?
To take out the coin.
Yep. Yeah, so this would dispense a coin.
Well, I remember because I know John probably has had one, and so did I, doing a paper route. And what you would do is you would put it, and you can see on the back, the little hooks, kind of like, you put it on your belt,
Yep.
right? And you could put it on your belt, and when somebody gave you money, you could just click out the change
Yep.
and give it to them. Does that make sense?
Yeah.
Okay, so that way you can put bills in your pocket if you needed to, or if somebody goes, hey, you know, I've got a quarter, but give me 2 dimes and a nickel or something like that. You could insert the quarter in there and then give them, just click down twice on the dime and once on the nickel, right? And how old is that one, do you think? I mean, that.
Not quite as old as the previous. Probably.
Yeah, I was going to say that a little after the Civil War there.
Probably 1920s-ish. I unfortunately couldn't find a lot of information in our paperwork about this particular piece.
Okay.
But I wouldn't imagine it's as old as 1800s. No, this is
Right,
this
and
is
I
probably,
mean, because I was using mine early 1970s, and I
This
know
one
that
is-
they were around before that.
yeah, this is probably a little bit before that. Latest probably 1940s, but probably earlier.
Right, because you would often see in big cities, you know, the kids with the papers, yeah, hey, paper here, paper, you know, and a lot of times they would have one of those, or something similar to that to use for their coins.
Yeah.
So that's nicely done, Lucia, that you noticed those things about that. Do you have any questions for Ashleigh about this item while we've got you ladies here?
No.
So do you have coins in it or can put coins in it?
I can put coins in it.
All right, let's take a look at this and see how it works. And so how about you put some coins in and then we'll dispense them also.
So that one's in. All right.
So yeah, put
There
them
you
all
go.
in first and then
Put
we'll
them all
see
in.
what.
Oh, there's 2 nickels and 2 quarters. Nope. Nope. There you go.
Yeah, 'cause it still will go in the same one. There you go.
There you go.
So sometimes
Press
if
hard.
you use,
There you go.
because
Press hard. There you go. Oh, there you are.
I was going to say, something just the physics of going like that may not be as easy because it was intended, you know,
was
you have
intended,
more force
yeah.
using your thumb like that.
Yes.
All right. So how much money do you think could be held in that?
A couple of dollars.
A couple of dollars? So do you think that would be a whole roll of quarters? Do you think that, have you ever seen a roll of quarters? No? Do you know how much is in a roll of quarters? Well, you've never seen one, but actually, could that hold a whole roll of quarters probably, or close to it?
Close to it, probably.
Yeah, so there's $10 in a roll of quarters, right? So let's say that's almost $10. How much do you think it would actually be? Do you think it would be at least half? Do Do you think it would be more than half? Because a roll of quarters is probably about like that.
More than half,
So about, what do you think?
like $8.
Yeah, there you go. That's exactly what I was going to say. It's probably $8, right? And that's good estimating, right? Now, as far as the pennies, right? Because a roll of pennies would hold 50 pennies, right? How many pennies do you think you could fit in there?
30.
Yeah, probably 30, right? A good number,
Yeah.
right? And then the nickels and dimes. So you know you've got at least 8 something, right? So you think you could put a total of $10 inside that little
Yes.
coin dispenser? I bet you would be able to do that also. Do you have $10 worth of coins we can put in there and test it?
No.
Neither do I. All right. Well, Ashleigh, we certainly do appreciate you taking some time to bring down another artifact.
Yeah.
And when you first saw that, what made you think about bringing that piece with you today?
Well, I hadn't seen it growing up, so for
You
me,
hadn't seen that growing up, so you're pretty young yourself. Then. All right, all right.
so when I saw it, I mean, I did very similar to Lucia here. Looked at it, noticed the numbers, the slots, figured out it was a coin dispenser, and went and researched it. And for the most part, it's used like manual fare collection and all
Right.
of that. So trolleys, trams, you know, what you were talking about.
Yeah.
Various ideas.
So if somebody wanted to
So-
see things like this, where is the Kern County Museum located for people that want to go visit the museum?
Off of Chester Avenue. This probably its closest relatives would be in some of our store, like cash registers in a sense, or in our trolley car.
All right, well, we can see the website up there, kerncountymuseum.org. That way people can find out some more information, where exactly it is, the hours of operation and things like that.
Yes, yeah.
And if they see you, can they bug you and give
Sure,
some information?
say hi.
There you go. Say hi to Ashleigh. All right, 6364357 is that phone number. And thank you once again to Ashleigh for coming in. And you dispense the coins, so the coins stay here. Is that what's going on?
I'll pick them up.
So, Lucia, are you ready to work on another problem?
Yes.
All right, head on over to the board. You and Cindy now are going to divide some fractions. So, Cindy's going to give you some fractions, and you're going to work on division. And if you need some help, that's what Cindy's there for.
What do you know about fractions so far with division? Have you done any division of any fractions before? Have you done multiplication?
Yes.
Okay. So what do you remember about multiplication? Let me write a multiplication real quick just to see. Tell me what you remember about that first.
I'm used to doing it like that.
So without this part?
Yes.
Okay. All right.
So I know that 3 means there's 3 holes. So 3 holes plus 1/3 equals 10 thirds. So bring it down.
So let me see. Hold on. Let me look at what you're doing, what you're thinking. So you have 3, and you want to multiply it by 1/3, right? Where'd you get your 10 from? Just explain to me what you were thinking there.
The 3 equals 3 holes, and so you add it to that, and
Oh, okay. I know what you're doing. You're thinking of when it's like this, how you make it into an improper fraction. That's what you're thinking of.
Yeah, because she got 9/3, added the one, got 10/3.
Yeah, I was just trying to figure out what she was thinking. Okay, so this is a little bit different though, because this is saying that, like if we said 3 times 2, we could also we have 3 groups of 2, 2 plus 2 plus 2. So this is saying we have 3 groups of 1/3, or we think of it as 1/3 plus 1/3 plus 1/3. That would be what this would mean. It's a little bit different than this. This is what you're thinking of. To make that improper, you multiply those and you add the 1. Yeah? So let's go back to this one then. So if you think of it as 3 groups of 1/3, what would you get?
4/3.
So let's see, if
Or
we had,
3/3.
okay, so if you had 3/3, do you know what that's equal to?
1 whole.
Okay,
So it's 1 whole.
so just to show you kind of what you could do, because I'm not sure what, like in 4th grade math, what part you got to already, or, you can think of it like this. Have you ever done that before?
No.
So 3 is the same as 3/1? You haven't seen that before? Because 3 divided by 1 is still 3. Okay, so when you see a whole number, you can put a 1 under it, and then if you just multiply numerator by numerator, so 3 times 1, what do you get?
3.
Yeah. And then if we did this way, for the denominators, 1 times 3,
3.
and look, we still got that, just in a different way.
So maybe do another multiplication problem like
Okay.
that, where you're multiplying a whole number by a fraction.
All right, let's see. Let's just change parts of this. Okay, so let's do 5 times 1/2. So do you want to try it thinking of it as 5 groups of 1/2, or do you want to try it the way I was just showing you?
The way you were just showing me.
Okay, so go ahead and give it a try. See what you remember, and ask me questions if you forgot a step I did, because that was like a real quick. So if you have 5 whole, what can you put under it to make it also be a fraction?
1.
Okay. All right.
And then 5 times 1 equals 5. And 1 times 2 equals 2.
Okay.
And 5 divided by 2 is 2. And remainder 1, it's be 2 1/2.
Nice. Nicely done.
Yeah,
And
so
that would
that
be your
part
answer.
you've got down perfect, right? Turning improper fractions into mixed numbers, right? And then I'm sure you can go mixed numbers and turn it into an improper fraction again. So now, try this, all right? So erase that problem. Let's go 4/10 times 2/4.
4 times 2 equals 8. And 10 times 4 equals 40. 8/40ths.
So then, have you learned to simplify fractions at all?
No.
So simplifying fractions is like trying to make the numbers as low as they can get, but still have the same value. So if you had 2/4, the original 2/4 here,
1/2.
so what we want to try and do is figure out what we can make this simplify down to. So what you do is you think of, okay, so I have 8 and I have 40. What number can you divide 8 and 40 by? That's the same number, and try to think of the biggest thing. So what can you divide 8 by, and what can you divide 40 by, but it's the same number?
4.
Okay, so go ahead and do that. Okay, so what will you get when you do that?
8 divided by 4 equals 2.
Okay.
And 40 divided by 4 equals 10.
Okay.
So it's 2/10.
So then when you look at your answer you have now, can you think of anything that you could simplify those two numbers by?
2.
Okay, so go ahead and do that.
One fifth.
And since 1 can't simplify down anymore, right? That's as far as you can go. So just going to go back to here. You thought of 4. You could have also thought of 8, because 8 can divide into 8 and 40, and then you would have got that still also.
So leave that problem on the board. We're going to come back to that problem in a little bit. But right now, we're going to find out a little bit more about ice in the ocean.
The Arctic region is hauntingly beautiful. It's a vast expanse of sea ice floating on water. Sea ice is actually frozen ocean water. It forms, grows, and melts in the ocean. Arctic sea ice plays a major role in the Earth's global systems. It keeps the polar regions cool, influences climate, and provides a habitat for many animals. But the amount of sea ice in the Arctic has been on a steady decline over the past 2 decades. In fact, the annual minimum area of sea ice is nearly 50% smaller now than it was in 1979. So, why is the sea ice shrinking? Arctic sea ice is melting at an alarming rate because ocean and air temperatures are getting warmer. Here's how. The burning of fossil fuels emits carbon dioxide and other heat-trapping gases into the atmosphere. The heat absorbed by these gases is radiated back towards the Earth's surface. Then, the ocean absorbs this heat from the air. As the ocean heats up, sea ice melts. The more the ice melts, the more ocean surface is exposed to the sun's rays. Unlike sea ice that reflects the sunlight back into the atmosphere, the dark surface will absorb it, warming the region further. The cycle of warmer temperatures and ice melt continues. In fact, air and ocean temperatures are rising faster than at any other time in history. If we are to understand how much and how fast the ice is melting, we need to be able to accurately measure it. If all of the ice in the Arctic Circle were to melt, life as we know it would be dramatically different, and not in a good way. That is why measuring how much is there, how thick it is, and how fast the ice is melting, both on land and in the ocean, is so crucial for understanding what is happening in a changing Arctic. There are 3 main ways that scientists measure Arctic ice: satellites, aircraft, and on-site or in-situ measuring. It is these multiple observations that provide a more complete picture and story of the ice. Scientists use satellite images to create an outline of the dimensions of sea and land ice, including the Greenland ice sheet. The measurements show how wide and thick the ice is in different regions. Some satellites measure small changes in gravity that reveal where ice sheets are losing mass, while others have used lasers to measure the height of ice above the land. To understand the rate of sea ice melt, scientists have placed submerged buoys, called moorings, at strategic locations in the Bering Strait and farther north. Devices are attached to the moorings that collect data on temperature, salinity, nutrients, currents, and the thickness of the ice above it. Using this data, scientists can calculate how much warm water is flowing north into the region, a potential source of heat for sea ice melt. To study ice melt on the Greenland ice sheet, scientists also use manned and unmanned aircraft systems. The aircraft carry a digital camera, atmospheric temperature and pressure sensors, an ice surface temperature sensor, and a laser rangefinder. The data collected from these instruments allow researchers to create 3D digital elevation models, which help calculate the thickness of the ice sheet. By putting all this information together, scientists can get a more accurate picture of how Arctic ice is changing, both on the land and in the ocean. As Arctic ice continues to melt, it will cause ripple effects across the planet. When the polar regions warm, even just a degree, it disturbs atmospheric and oceanic patterns. The patterns of the jet stream will be affected, which may lead to more extreme summer and winter weather events in Europe, Asia, and North America. Not only will our weather change, but sea level will rise too. Sea ice melt itself does not cause sea levels to rise because the ice is already in the water. But the melting of ice on a land surface like Greenland does, because new water is flowing into the ocean. In addition, as ocean water warms, it expands, which also raises sea level. Warmer air temperatures will accelerate the melting of Greenland's ice sheet, which contains enough ice to raise global sea levels by more than 20 feet. Sea ice creates a unique ecosystem that supports millions of plants and animals, from krill and ice algae to cod and walruses. Both the topside and underside of the ice provide places for animals to hunt, hide, rest, mate, and give birth. Without sea ice, Arctic plants and animals must either adapt or migrate. If they can't, they will go extinct. If that isn't enough, People who live in coastal communities within the Arctic Circle are also battling erosion along their coastlines. Sea ice serves as a buffer against wave action. Without it, the wind blows across a larger region of open water, resulting in stronger winds and bigger waves that erode the shoreline. These communities must relocate inland, or their homes and land could be washed out to sea. For ice in the Arctic, it's a race against time. If humans do not change what we are doing to the global climate, the ice will continue to disappear, and life as we know it will be altered.
Definitely a lot of stuff to think about right there as far as the ocean ice. And something to think about right now, young lady. You ready for a money problem?
Yes.
All right, so think about that coin dispenser that Ashleigh brought in, all right? And you have it, all right? And I'm going to buy something from you, little pad of paper or something, all right? And it costs 65 cents. And I give you a $1 bill, and it costs 65 cents. What kind of coins am I getting and how many?
You'd get a quarter, 1, and a dime, 1.
And is that it? All right, pretty good, pretty good. 35 cents is exactly what I would get, and that's nicely done doing that in your head, because that's what those people had to do all the time, right? Because you wouldn't have time to get a calculator and things like that, so I bet you'd get yourself a little gig like that. You know, get yourself a coin dispenser, go out, hey, look, hey, you want a little something? Here we go. All right, you ready to get back to your math problem? All right, so I'm going to have Cindy go over something with you real quick, because you got to 1/5, which was correct. But as you get a little bit older in some higher level math, you're going to learn some things that will make it quicker to get there. All right?
You want me to use the same problem?
Yes, use the same problem.
Okay. So, you know how after you solved it and you got 8/40 as your first answer, and then we thought of things that we could divide it by to get it down to its simplest form. So there's a way that's a little bit more efficient, and that is looking at the problem and you want to look diagonally. Well, you could also do it top to bottom if you can simplify, but let's start with diagonal. So diagonally, you think, okay, if I have 10 and 2, what can I divide them both by?
2.
Okay, so if I divide this by 2, what am I going to get?
1,
If I divide this by 2, what am I going to get?
5.
So we just simplified 2 and 10 before we even solved our problem. So then when we look this way, diagonally, what can 4 and 4 both divide by?
2.
And?
4.
Yes, you want to use the biggest because it's going to get you to your answer faster. So if I divide 4 by 4, what am I going to get?
1.
All right, and if I divide 4 by 4 here, I'm going to get?
1.
Okay, so this is what I have left now, 1 and 1 and 5 and 1, right? That's called cross-canceling. You cross out what you can diagonally, what you can divide them both by. So then you just multiply straight across, numerator to numerator, denominator to denominator. So you would do 1 times 1.
1.
Yeah, so go ahead. You're closer to that side. And then you would do 5 times 1, the numbers you had left there.
5.
So it would be 1/5. Just like what you got.
Does that make sense to you how that kind of works like that?
Yes.
All right, let's try another one.
All right, here I can erase
Clear the
whole
board.
thing like that.
So let's go 3/10
All right.
times 4/9.
Okay. So I'm going to let you try to think through the problem. Diagonally, you want to look at the numbers, and you want to see if you can divide them by something that's common. So which one do you want to start with? 3 and 9 or 4 and 10?
3 and 9.
Okay, so 3 and 9.
3.
Okay, so go ahead and divide them down. Cross them out and put what you get when you divide them. Okay. All right.
Now, 4 and 10. 2.
Okay. Okay. So now you're just multiplying.
2/15.
And then you would want to check, your final answer and make sure you can't simplify it, because sometimes people don't notice in their original problem. But since 2 can't go into 15, right? You got it.
All right, nicely done. So you do understand that now a little better, right? Good, that's what I wanted you to do. So now let's try one division of fractions, all right? So Cindy, let's do one where we're going to, instead of multiplying fractions, we're going to divide fractions.
All right. Oh, you want me to make it up, or you're going to tell me?
Yes.
What? All right. Let's see. 2/3 divided by 1/6. All right, so this is different, because when you have division and it has fractions in it, it's not just dividing like this, okay? So if you think of something like, if I wanted to divide 1 by 1/2, and so I think of this as one whole, and I divide it into halves, right? I'm dividing it into halves. How many pieces do I end up with?
2.
Okay, so this equals 2, because I ended up with 2 pieces. So what happens is, we take the second fraction, the one after the division, and we do what's called the reciprocal. Have you ever heard of that? So you flip it over. That's called the reciprocal. So I would have made this 2/1. I leave this one the same, and this changes to multiplication. And that's just a way to get that 2 without having to draw it out, all right? Because it gets weird when you don't have a whole number and you're dividing into parts, because you can't draw a picture easily, right? So that's what we were going to do here. So we're going to leave this one, and then we're going to do the reciprocal of that. Do you remember what reciprocal is?
Flip it upside down.
Yeah, so go ahead. We're going to put a little times right here, though. Go ahead. Okay, so this is going to change. This part changes. As soon as you do the reciprocal, it makes the switch to a different operation. It switches it to multiplication. So now, guess what? It's just like that problem now. So you check and see if you can reduce or simplify diagonally, cross cancel if you can. So what are you dividing them by?
1,
So if I divide 2 by 1, what do I get?
2.
Yeah. So it didn't change it, right? Anytime there's a 1, that's all you can divide by. It's not going to change it, so it's going to stay a 2. And that's going to stay a 1. You can't always divide things down. All right, what about the other way? Can you do anything that way?
3.
Okay. And then you divide that one by 3. And then,
Multiply them.
right. So now you have your
Equals
2
4.
times 2.
And then multiply 1 times 1 equals 1.
And do you remember what 4/1 equals?
No.
So do you remember how we had to add a 1 underneath, like when we had just like, we could have went like, oops, that to make it into a fraction? So if it's 4/1, that's like 4 divided by 1. What's that equal?
4.
Yeah, just equals a whole number of 4.
There you go,
There you
nicely done. So I'm going to give you one more to start on, so go ahead and clear the board. So we're going to use some pretty common fractions. 3/4 divided by 1/2. Yeah, there you go. Hold on a second. Let me see if I can help you out here. Let's get rid of that one, and we'll...
I touched it with
There
my
we go.
shirt. I should have you write it. Divided by what?
1/2. So I'm going to give you,
Okay.
Lucia, some time to work on this, right? So I want you to think about, you leave that first one, right? And then you do the reciprocal of the second one, but then you change the operation, all right? So I'm going to have you work on that while we take a look what's new this week at NASA.
Studying the health of our oceans and climate, a private astronaut crew heads home from the space station. And some mission milestones for our Lucy spacecraft. A few of the stories to tell you about this week at NASA. Our PACE Earth Science mission launched aboard a SpaceX Falcon 9 rocket on February 8th from Cape Canaveral Space Force Station. The mission will help us better understand how our oceans and atmosphere exchange carbon dioxide, measure key atmospheric variables related to air quality and Earth's climate, and monitor ocean health, in part by studying phytoplankton, tiny plants and algae that sustain the marine food web. Follow the mission at blogs.nasa.gov/PACE. On February 7th, a SpaceX Dragon spacecraft carrying the 4-person crew of Axiom Mission 3 undocked from the International Space Station to begin the crew's return trip to Earth. Axiom Mission 3, the third all-private astronaut mission to the orbiting laboratory, will return with more than 550 pounds of NASA hardware and data from experiments the crew conducted during the mission. Our Lucia spacecraft recently completed the second and largest planned main engine burn of its 12-year mission. These burns, combined with the mission's second Earth gravity assist maneuver targeted for December 2024, will help Lucia transition from its current orbit around the Sun to a new orbit that will carry it beyond the orbit of Jupiter and into the realm of the never-before-explored Jupiter-Trojan asteroids. On February 3rd, our Juno spacecraft made a second close flyby of Jupiter's moon Io. Like Juno's previous flyby of Io in late December 2023, this second pass took Juno about 930 miles above Io's surface. The twin flybys were designed to gain new insight into how the moon's volcanic engine works and investigate whether a global magma ocean exists under the moon's rocky, mountainous surface. That's what's up this week at NASA. For more about what else we're up to, check out nasa.gov.
Always interesting things going on at NASA. Lucia, how did you figure out that last problem?
I brought down the 3/4 and the 1/2, and I changed the 1/2 to 2 1s, and I multiplied them. So 3 and 1 can go into 3. So that changed to 3 and that changed to 1. And then 2 can go into 4 2 times. So that equals 2, and 2 divided by 2 equals 1. And then the 3 and the 1, I multiplied them, and I got 3, and then I multiplied the 2 and the 1 and got 2. So it equaled 3 halves, but 3 halves is 3 is larger than 2, so that equals 1 whole, and then there's still a 1/2, so it's 1 1/2.
All right, nicely done. Come on over here, young lady. That was a great explanation right there. And you also got a little bit of work with fractions today that you haven't quite done in 4th grade yet, right? And some vocabulary with reciprocal and things like that also. So did you learn a little something today? Good. Did you have fun today? Do you think you would like to have one of those coin dispensers and walk around and make change like that? That'd be pretty cool, right? Hey, we do have phone tutors available until 5:30. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.